Hello Year 6, good morning or good afternoon depending on when you're watching this video. Hope you're having a lovely day so far and you're ready for some arithmetic. Now this short video, and I will make it short today I promise, does contain some new learning as well as some revision. So even if you've only done the sort of questions for the year 5 and 6, you might want to watch the first part of the video just to do some revision. Now as you watch, you might want to have a piece of paper and a pencil ready, and you could in fact mark your own work as we go through and edit any answers or errors that you've sort of got incorrect, like we normally would at school. Then when you've finished your work, Year 6, don't forget to send it to me on Class Dojo so that I can give you any support that you need with your learning. We've all made excellent progress in our arithmetic since September, and I'd feel really sad if any of you stop making this progress because you're not asking for any help or support that you need, or I can't see your work to know that you need some support. So I'm going to start with the lower key stage questions, and then I'm going to go on to the year 5 and 6 questions. Okay, so question number 1. 364 subtract 8. Now I'm going to use a number line to help me with this one. It's a really good visual method if you don't feel very confident with these sorts of questions. So I've got 364 and I need to subtract 8. Well, I know that I can have two parts to 8, 4 and 4, because 4 add 4 equals 8. Now if I look back at this number, I've got 364, so I can easily subtract 4. Just removing these 4 ones, I'd be left with 360. So I've subtracted or taken away one lot of the 4. But actually I know I've got another lot of 4 to take away. Okay, we can use our number bonds to help with this one. 360 subtract 4 will be, that's it, well done, 356. And now I've subtracted the second lot of 4. So in total I have subtracted 8. I've just done it in 2 jumps there to help me. Of course, another way to do it, you might have added subtract 10 and added 2 back on. That's another way of doing it as well. Okay, let's have a look at question 2 then. And I've written the fractions out over here to help us. We've got 3/5 add 1/5. Now, when we're adding fractions or subtracting fractions, what's the first thing we need to check, Year 6? Well, remember, we need to look at the denominator or the bottom number. Now, if they're the same, that means we don't need to convert the fraction, and the answer will have the same denominator. So what do I do next? That's right, I'm looking at the numerators now, the numbers on the top, and I'm doing 3 add 1, which is 4. Okay, now hopefully Year 6, you're looking at that fraction and you're thinking, I can't simplify that fraction. Why can't you simplify it? Well spotted, we've got 5 here, and we know 5 is a prime number. That means it can only be divided by 1 on itself. Therefore, we know we can't think of a divisor that sort of will go into 4 and 5 equally. Okay, let's have a look at question number 3 then. Now normally you'd see question number 3 looking like this on a page, and I do apologise, I can't do that on the computer, so there's just a little reminder there of what it would normally look like. Now what does 7 squared mean? 7 times 7, well remembered everybody, and 7 times 7 is 49. So if you've got 49, you can give that a neat little tick. Okay, question number 5 then. We've got 143 divided by 100. Now, year 6, you know, if we are dividing by 10, if we're dividing by 100, as is this case, or if we're dividing by 1,000, we draw something at school to help us. What do we draw? Well done to everybody who remembered that we draw a place value chart. And you're really familiar with this technique, year 6, and you're good at just getting on creating that help resource for yourself. Okay, so don't be afraid to do things like that, even though you're still at home. Now I've got one over here that I've sort of prepared for us. So I'm doing 143 divided by 100. So I'm going to start by putting 143 onto my place value chart. And I've checked that the digit in the hundreds column is in the right place, the digit in the tens and the ones is lined up accurately. Now, when we're dividing, is our answer going to be bigger or smaller, year 6? You're right, it's going to be smaller, which means I've got to move each digit to the right. That's the way it's going to make the number smaller. There's a little bit of logic there for you. Now, if you're dividing by 100, we need to make this 100 times smaller. And to do that, we move each digit 2 places to the right. Some people like to remember it by the amount of zeros that are on the end of the 100. So 2 zeros, 2 places to the right. So we're going to go 1, 2, over to the 4, 1, 2, and over to the 1 digit, 1, 2. And some of you will have spotted we now need a decimal point. So we have 1.43. Okay, if you've got 1.43, give it a neat little tick. Now, the flashback for them. Now, we want to, for question 1, we are calculating the product of 12 and 0. And you'll know, year 6 from our learning in class, that to find the product, you will need to multiply or times. So we will need to do 12 times 0, or 12 lots of 0, which will equal 0. Well done, everybody. Okay, question number 2 then. Divide 3,900 by 100. Oh, we're dividing again. Dividing by 100. So what's our first step? That's right, we're going to use our place value chart. So if you haven't got one at home, you can draw it out now to help you. Pause the video and have a go. Okay, hopefully you've got an answer then. So I'm going to put my number onto my place value chart, taking care to put the 3 in the thousands column, the 9 in the hundreds column, and the zeros in the correct column. Now, because we are dividing, the answer is going to be smaller, so logically we've got to move it to the right. It's the only way it's going to make the number smaller. Can you remember how many places we've got to move it to the right to make it 100 times smaller? Well done, we're going to move every digit 2 places to the right. So 1, 2, 1, 2, 1, 2. And you would have spotted that we need a decimal point. So we've got 39.00. Now I'm just wondering, year 6, do we need to keep the 0.00 or can we cross it out? Is 39 the same as 39.00? What do you think? Yes, it is exactly the same. You actually don't need to put these those digits on the end, because whether you've got the digits there or not, it's still the same number. There's still no tenths or hundredths. Okay, so we're going to draw a rectangle now with a perimeter. So we've got to draw, and it's got to be a rectangle. So we know that a rectangle has 2 longer sides and 2 shorter sides, with a perimeter of 12 centimetres. So a perimeter, can you remember what perimeter means? That's right, it's the space or the length all the way around the outside, and it's got to total 12 centimetres. So we're going to come down to this rectangle that I've drawn down here. Now it's got to total, or the perimeter I should say, has got to total 12 centimetres. So if I was to add up the lengths of each side, it will total 12. So let's think what I could do. I could put 4 centimetres on this side, which means that this side will automatically be 4 centimetres because we know they measure the same. 4 add 4 is 8, and I've got 4 more centimetres to make 12. So I could put 2 centimetres here, that makes 10, and 2 centimetres here makes 12. Now some of you might have done that slightly differently. Okay, some of you may have thought to yourself, well, I know 3 times 4 equals 12. So therefore I know 12 divided by 4 equals 3. Now, can all of these sides be 3 centimetres? What do you think? 3, 6, 9, 12. Well, that does total 12, but are these lengths the same size? Well, these two parallel ones at the top and bottom are, but certainly in a rectangle, the two width sides are different. So what will they need to be? What do you think? We've got 6 now. 7, 8, 9, 10. Well, that still doesn't give us 12. We've still got 2 centimetres to play with. So what happens then? What could I do? What happens if I... Are there any other ways that I could do this? I'm going to leave you to think about that, Year 6, because I don't want to give you any answers today. I want you to be doing a bit of thinking for yourself. Is there any other lengths that this rectangle could measure to give a total of 12? Let you have a think about that one. Now, question 4. You've got to calculate 3,923 add 941. Now, we've been using the column addition method for these sorts of questions. Now, when you do this in your book, remember that 1 digit goes in each square, and you need to line your digits up accurately. So all the ones are in line, tens, hundreds and thousands. So we start in the ones, we always start with the ones. We've got 3 add 1, which is 4. Then we've got 2 add 4, which is 6. 9 add 9, which is 18. 3 and 0, nothing here, but we've got 1 down here, so 3 and 1 is 4. 4,864. Okay, we're going to go on now to the 5 and 6 arithmetic questions, and we're going to start with 3,572 times 56. Now, grown-ups at home, I know the children are really confident with these questions, so I can move through this one quite quickly. There shouldn't be anything that sort of confuses people with these. So we start with our ones. I've set up my question here, just like you have in your book. Start with our ones. 2 times 6 is 12. Don't forget year 6, we want that little 10, that little 1, and the big 2. Now 7 times 6 is 42. Add the 1 we've carried, which will be 43. 5 times 6 is 30. Add the 4 we've carried, 34. 3 times 6 is 18. Add the 3 we've carried, 21. Okay, now we've multiplied everything by the ones digit, so we're now into the tens column. I've got to put my 0 here to represent the 10 of 50. I'm now into that, into that bigger digit now. So 5 times 2 is 10. 7 times 5 is 35. Add the 1 I've carried, 36. 5 times 5 is 25. Add the 3 I carried, 28. 3 times 5 is 15. Add the 2 I carried is 17. And then the last step, year 6, what do I need to do last of all? That's right, I need to calculate my total by adding them up. So 2 and 0 is 2. 3 and 0 is 3. 4 and 6 is 9. 8 and 1 is 9. 7 and 2 is 9. So we've got 99,932. Okay, we're going to look at question 2 now. We've got 5/6 divided by 9. And I've set it up over here so it's a bit easier for us to understand and to look at. Now, we might be looking at this one thinking, what on earth have I got to do here? This is really tricky. But actually, year 6, I know you can do this. Okay, I've seen you do this at school. So the first thing we need to do, we actually have to multiply the denominator by the whole number. So we do 6 times 9. And I know it says divide, but you'll remember in school that it is actually a multiply. So 6 times 9 gives us our denominator. And 6 times 9 is 54. Then we come to our numerator, the number on the top. We don't actually need to do anything with that one. That one stays the same. And again, I'm going through this quite quickly, year 6, because I know it's something we've covered in school. Now, we've got our final answer, so we know 5/6 divided by 9 is 5/54. What question do I have to ask myself at this point? Well done. We think, can I simplify? Well, what do we know about 5? That's right, 5 is a prime number. And what does that mean if something's a prime number? Well remembered, it means that it can only be divided by 1 and itself. So we can't simplify this fraction. It's in its simplest form already. Okay, number 3 then. We've got 0.8 multiplied by 7. Now I know lots of you feel most confident doing this using the column method, and we're going to recap how to do it, but I'm also going to show you a different way today. Now we start by setting up our column multiplication in our book. So we've got 0.8 multiplied by 7, and we can get our lines drawn ready to go. Now we start in the ones just like we always do, and 8 times 7 is 56. 0 times 7 is 0. Add the 5 on that I carried, pop the decimal point in the right place. 5.6. So yes, that is one way that you could do it. However, you could also do this. Now, to begin with, I could ignore this 0 and the decimal point. So I'm left with 8 times 7, which I know is 56. Now, if I think about where this decimal point is, I know I've only got one digit in what would be the tenths column. This would be the ones, for example, on our place value chart. So I know that in my answer, I've also got to have one place after the decimal point. So I can put it in the right place using that knowledge that I've got. Okay, question number 4 then. And we've been doing lots of long division practice in our maths this week, so hopefully you've had a really good go at this one. Now, we're trying to work out 2,340 divided by 36. So how many times does 36 go into or divide into 2,340? I'm going to use the bus stop method to help me. Now I start by thinking 36 into 2 doesn't go. 36 into 23 doesn't divide into it. 36 into 234. Well, I could sit here and write out my multiples of 36, but that's going to be quite time consuming. So instead, I'm going to think about what I know. I know 36 times 10 would be 360, which is greater than 234. So it's too far when I'm trying to think how many times does 36 go into 234. So I know that 36 times 5 would be half of this answer, which would be 180. Now that's too small, that's less than this number. But what I'm going to try and do is 36 times 6, because I think that would give us something close to this number. So 6 times 6 is 36. 3 times 6 is 18. Add the 3, 21. So 36 goes into this number 6 times, goes into 234 6 times, and that takes you to 216. Okay, at this point I need to do a subtraction. I need to find out my remainder. So 4 subtract 6, I need to exchange. 14 subtract 6 is 8. Well done, everybody. 2 subtract 1 is 1, and 2 subtract 2 would be 0. So now I'm thinking 36 into 18. That doesn't go, so I've got to bring this digit down here. 36 into 180. Well, I've already thought about that. I know 36 times 5 is 180. So 36 divides equally into 180 5 times. Okay, I've divided all my digits now, so I know my answer is 65. Now, year 6, I know that that takes a lot of thinking. So if somewhere in your working out today you've made a little bit of a calculation error, I'd like you to pause the video now, please, and have another go at that question. And then it would be fabulous if you could send me your editing so that I can see that you've really thought about your learning today and you're still thinking about making that good progress at home. Okay, so our final question of this part is 32,756 subtract 5,438. I'm going to whiz through this one really quickly, as I'm sure all the year 6s at home are feeling very confident about this one. So I couldn't do 6 subtract 8 because that would give me a negative number. So I've exchanged and now I've got 16 subtract 8, which is 8. 4 subtract 3 is 1. 7 subtract 4 is 3. And 2 subtract 5 I can't do and give me a negative, so I'm going to exchange again. So this time I've got 12 subtract 5, which is 7. And 2 subtract nothing is 2. Okay, I'm just going to go through and double check that to make sure I haven't made any errors. Ooh, this one doesn't look quite right to me. 12 subtract 5. Well, if I take away 2, that's going to be 10. If I take away the 3, oh, I have got that one right. Yeah, okay. Right, so let's have a look at our flashback then. Now, we are calculating 939 divided by 3. So, I've got my bus stop method here. And again, we should all be feeling fairly confident with these now. So 3 divides into 9 how many times equally? 3, 6, 9, 3 times. If you're not sure, you can write out your multiples of 3 to help you. 3, 6, 9, 12 if you need to. So now we're thinking 3 divides into 3 equally once and 3 goes into 9 3 times. 313. Okay, we're going to calculate now. 6,710 add 4,290. And again, you might have used the column method for this one, or you may have done it mentally. Let's see what we get. 7 add 2, 7, 8, 9, 1 is 10. 6 add 4 is 9, and 10. Okay, hopefully you got 10,000. And again, just like we do in school, I'm going to go through and double check. 0 and 0 is 0. 1 add 9 is 10. 7 add 2 is 9. Add the one we carried is 10. 6 add 4. Add, yeah, 10,000. Okay, so which is greater? 5 million. Oh, it's always handy to have a place value chart for these, I find. So let's put 5 million on my place value chart. So 5 million, I've checked I've got the 5 in the millions column. Which is greater, 5 million or 500,000? Let's put our 500,000 on our place value chart. Which one is bigger then or greater? That's right, 5 million. We can actually see it's 10 times bigger. Okay, what is the size of this angle? Now, we haven't done much work on protractors at school, so this may have been a tricky one. I'm going to see if I can make it a bit bigger to help us. Like I say, this might have been a little bit tricky for some people, only because we haven't looked or done much work with protractors. Okay, that's a bit better, isn't it? Hopefully you can see that a bit better at home. Now, with a protractor, what you'll notice is that we've lined the sort of straight line at the bottom of the protractor here. Now you make sure that that straight line lines up or matches with the base of the angle. Okay, and when you're measuring, you're actually measuring the size of the angle, which is this bit in here that I'm just marking in purple. That's the bit you want to measure. Now you do that by putting your base of the triangle at 0, so you can see you've got 0 here, and then we follow round to see how far we get round our protractor. So this is measured in degrees. So we've got 10 degrees, 20 degrees, 30 degrees, 40 degrees. And we record degrees with our little symbol, a little circle at the top, just by our 40. So this angle measures 40 degrees. Okay, Year 6, that concludes our arithmetic for today. Please send me your learning so that I can support you with anything you found tricky. Have a lovely day, everybody.